Hello, everyone. Welcome to today's live broadcast, New Trends in Hygienic Diaphragm Valves that Improve Reliability. This is Jennifer Markarian, Manufacturing Editor of Pharmaceutical Technology, and I'll be your moderator for today's event. We are delighted to bring you this educational web seminar presented by Pharmaceutical Technology and sponsored by ITT Engineered Valves, a global manufacturer of industrial and hygienic valves for the pharmaceutical, bioprocessing, chemical, power, pulp and paper, and mining industries. With 75 years of experience, Engineered Valves is committed to delivering high-quality, innovative fluid control solutions. For more information, please visit www.engvalves.com. We have a few important announcements before we begin. This webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit questions by typing them in the Q&A box, which can be found on the left-hand side of your screen. You can enlarge the slide window by clicking on the small green icon in the upper right-hand corner of the slide window, or by hovering your mouse over the lower right-hand corner and dragging the window to the desired size. The slides will advance automatically during the event. If you have any technical problems viewing or hearing this presentation, please click on the question mark Help widget in the dock at the bottom of your presentation window. Please note the resources available from our sponsor, which you can locate in the green resource widget below your presentation window. I would now like to introduce today's speakers. We are pleased to be joined today by Paul McClune and Richard Kovac. Paul McClune has been managing the PureFlow Diaphragm Valve brand for ITT Engineered Valves for more than 15 years. He is currently an ITT Global Product Manager, where he is responsible for the development of global marketing strategy, driving products and programs for the ITT PureFlow Diaphragm Valve, a global product line worth more than $40 million. McClune was previously a senior product engineer responsible for the design and development of the PureFlow Diaphragm Valve product line. He earned a Bachelor of Science degree in Mechanical Engineering from the University of Pittsburgh and has more than 25 years of experience in product management, design, and development. Rich Kovac has over 30 years' experience in product design, engineering management, and product development. He is responsible for developing new valve products for all of ITT's key markets, including biopharm, chemical, power, and mining. He recently led the development and launch of the award-winning Envision Hygienic Diaphragm Valve. He earned a BS in Mechanical Engineering from UNC Charlotte. He is a member of ASME and PDMA and is a registered professional engineer. Thank you both for joining us today. And Paul, you have the floor.
Thank you, Jennifer. I believe we have attendees from all over around the globe, so I'm going to say good morning, good afternoon, and good evening to everyone. Let's get started. For today's session, we have the following 3 learning objectives. We're going to understand why diaphragm valves leak. We're going to uncover 4 root causes that can affect the diaphragm performance and reliability. We're going to learn how maintenance best practices can lower contamination risks, alleviate lost batches, and increase profitability. We also will understand how new technology in valve design can increase productivity, extend maintenance intervals, and reduce downtime, ultimately reducing overall total cost of ownership. But first, let's discuss why diaphragm valves are utilized in biopharmaceutical, food and beverage, and other hygienic applications. First off is the hygienic design. The diaphragm valve is superior in cleanability and has minimal areas for contamination. Diaphragm valves have minimal holdup volume and are drainable as compared to ball valves that are significant fluid retention in the ball cavity. They're capable of a wide range of applications. SIP, CIP, hot and cold WFI, as well as cold processing conditions are common for diaphragm valves. So while diaphragm valves are the cleanest and most drainable valves available for hygienic process applications, because most of them are wide-range processes going through these valves, they can be susceptible to leakage over time. We are going to discuss the 4 major root causes that adversely affect the performance and reliability. First, we should define the types of leakage that diaphragm valves can experience. First, there's shell leakage, which is leakage to the external pressure boundary. Then there's seat leakage, which is through the valve body or through the valve diaphragm itself. And then thirdly is diaphragm rupture, where the actual diaphragm fails and process fluid enters into the body or bonnet of the valve. We should also talk about diaphragm materials. There are two major diaphragm materials used within the hygienic market in biopharm. First off is PTFE or Teflon diaphragms. They're well known for their chemical resistance and steam resistance, but due to the hard plastic characteristics they exhibit, they can be difficult to seal at times. And then there are EPDM and other common elastomers that are selectively used. These are known for reliable sealing, but are limited in steam resistance and can be susceptible to chemical attack. So the big question, why do diaphragm valves leak? First off, there's four main broad categories. General maintenance issues such as body-to-bonnet assembly, body-to-bonnet fastener condition, as well as diaphragm installation errors are the main issues. Also, when attempting to extend diaphragm usage to longer than useful service life, you eventually have issues with preventative maintenance intervals and failures. The maintenance issues. There are three primary general maintenance areas of concerns. The fasteners, as I mentioned earlier, valve body cleaning, particularly from previous leaks, improper or no torque practices being used. Some examples of incorrect torquing, such as using only single pass to get a final torque, an incorrect torque pattern, not using a crisscross pattern, as well as no retorquing after thermal cycles. Also, excessive or inconsistent torque can be applied. Fastener condition. Quite often, the biopharm industry avoids the use of lubrication due to contamination concerns. However, the use of stainless on stainless fasteners will generally lead to galling, which is due to the lack of lubrication. The lack of lubrication causes torque reading errors as well as installation errors of range of 40 to 50%. As a result, the clamping force of the valve joint is greatly reduced. This chart shows how quickly clamping force is reduced when fasteners are reused without lubrication. The y-axis is the clamping force on the joint, while the x-axis is the number of times fasteners are reused. As you can see by the bold curve in the middle of the chart, 20 to 25% of the clamping force was lost after only the fifth use. Diaphragm installation error. This is also another common area of concern. Threaded diaphragms that are assembled to the top works of the valves are commonly over-threaded or under-threaded. PTFE diaphragms or Teflon diaphragms are particularly problematic to this condition. Errors will cause permanent sealing bead damage, which is also called point loading, which can lead to diaphragm rupture and leakage through the valve. Service life. All the valve diaphragms have a useful service life. There are many factors that must be considered to determine the useful service life of the diaphragm. First, the user needs to determine the desired performance criteria. Is that length of service, the forgiveness of installation practice, total cost of ownership, or other factors? First and foremost is diaphragm material must withstand the pressure and temperature requirements of the application. They must also resist the chemical properties of the process media. You also must consider the overall condition of the valve sealing surface. Is the surface scratched, pitted, or does it have residual media? Also, how many times is the valve expected to open or close? Lastly, in most cases, the important factor is the magnitude or the frequency of the thermal cycles of the valve. Okay, this chart illustrates the typical performance of diaphragm valve over repeated thermal cycles. The test that is shown here is the ASME Appendix J test that is utilized to assess the performance of seals and diaphragm valves in repeated steam and cooled ambient cycles. This red curve illustrates the decline of seal integrity over the repeated process of thermal cycles. This capability decline will eventually lead to an external leakage when the curve intersects the process pressure. Okay. ITT also has many customers that utilize elastomer diaphragms in their processes. Some customers cite the need for reliable sealing for sterility reasons as the reason they use EPDM diaphragms. They're also forgiving and have less stringent requirements for torque practice. However, many believe that you can install an EPDM diaphragm without proper care. You can be careless with your practice, but this chart shows how this practice can result in less than reliable service. The first green bar is representative of EPDM diaphragms that are installed with the manufacturer's recommended torque practice, and you can see 10 out of the 10 performed well. When uneven torque practice was used, you can see in the second set of bars that 40% of the diaphragm showed notable signs of wear and damage. Thirdly, when the excessive torque was used, the last set of bars, 80% had notable signs of wear, and even more concerning was that 20% showed significant signs of damage. The message here is that even with the more forgiving elastomer materials, you must take care in your torque practice. So now we have a polling question.
Thank you. Yes, please click directly on the screen to submit your answer to the question that you see. The question is, which do you see as the most common issue at your operation? Maintenance issues, fastener condition, diaphragm installation error, or diaphragm usage beyond service life? I'll read that one more time, and please click directly on your screen. The question is, which do you see as the most common issue at your operation? Maintenance issues, fastener condition, diaphragm installation error, or diaphragm usage beyond service life? And now we will pull up the results to our polling question. And as you can see, we have no one answered with fastener condition, but we have 38.5% answered maintenance issues and diaphragm installation error, and 23% answered diaphragm usage beyond service life.
Very even distribution, sounds like. All right, thank you, Jennifer. So, maintenance best practices. So what can the industry do to improve reliability and minimize the potential for leaks, avoiding those huge costs of contamination and potentially lost batches? Always follow manufacturer's instructions. The major root causes of failures are addressed in the maintenance manuals. Pay particular attention to the diaphragm installation, torque and retorque recommendations, as well as the fasteners. Consider partnering with your diaphragm valve supplier to get the most of your process. Diaphragm installation issues. For two-piece PTFE diaphragms or Teflon diaphragms, the most common error that we see is that PTFE diaphragm is not inverted at the time of installation. As you can see from the graphic on the far left, the PTFE material should be flexed into an inverted state. This procedure allows the PTFE and elastomer backing cushion to mate together closely. If you do not perform this step, it will often result in point loading, damage to the center of the diaphragm. Secondly, torquing and retorque procedures. Once you have the diaphragm installed correctly, we move on to the actual valve assembly. This requires the fasteners to bolt to the valve body and the top works. You should use new or lubricated fasteners. Slightly open the valve to avoid torque values from being affected and the diaphragm bead from being damaged. Hand tighten the fasteners, then proceed to make multiple passes with a torque wrench building up from a hand tight to a final value. ITT recommends 3 passes. As in any bolt pattern, a proper crisscross sequence should be used. When retorquing, it should be done as close as possible to ambient conditions. All right, so we have another polling question.
Okay, we'd again like your participation. The question is, do your maintenance personnel use torque wrenches? And the possible choices are yes, all the time, most of the time, occasionally, or rarely or never. So again, please click your answer right on your screen. Do your maintenance personnel use torque wrenches? Yes, all the time, most of the time, occasionally, rarely, or never. And then you click on the screen and hit submit, and we will pull up the results to that polling question. Okay, so most are using torque wrenches most of the time, and then some all of the time, and a lower percentage occasionally or rarely or never. So that sounds like a good answers. So we continue the presentation?
Sure. We certainly like the rarely or never one there. So continuing on, fastener best practices to optimize reliability. You always want to assess the condition of the fasteners. Even though the polling question indicated that that wasn't of major concern, what we have found at ITT is that it is quite often a condition that is not realized by the customer as to affecting the performance of the valve with regards to leaks. So you always should assess that condition. A nut should freely spin with finger pressure going down the fastener. It should be very easy to assemble without a wrench. We always recommend the use of lubrication if it's allowable. We do understand that some customers use FDA acceptable lubrication such as White Knight or some other greases that are available out there. We've also found that even something such as WFI or water actually works as a lubrication as well for fastener installation. Obviously, you should replace fasteners frequently if no lubrication is used, if any wear or damage is found on those fasteners. Lastly, we suggest that you partner with your diaphragm valve manufacturer. To maximize the performance of your diaphragm valves, always consider partnering with your supplier and adopting their best practices. The diaphragm valves are a complex system of valve body, diaphragm, and top works that are specifically designed to work together. Using components that are not recommended by the manufacturer will result in unknown and unreliable performance. To make major improvements, consider collecting duty cycle information and develop a risk-based preventive maintenance program in coordination with your supplier. Also, consider adopting the use of standardized tests, such as ASME BPE Appendix J, to help gauge the performance of your specific situation. So in summary, problems with today's technology. There are many nuances to diaphragm valves and their assembly and maintenance. You have to consider threaded fasteners. Can they be worn, galled, or lost? You must torque and retorque quite often after thermal cycles. It takes time, significant time, to torque properly, multi-pass techniques, using torque wrenches, limited access that you may have. ITT has conducted studies that indicates that it takes upwards of 23 minutes to change a diaphragm and properly torque a valve. Access is limited to using proper tools, isn't always possible, and lubrication is important but seldomly allowed. Diaphragm require care and some level of judgment to install correctly. Okay, lastly, a summary, thermal cycles. Thermal cycles degrade the performance of the valve. The passive elastomer backing cushions that act as a spring to keep the joint free from degradation after each thermal cycle take a compression set, and cold flow of PTFE affects the current capability of the diaphragm. Leaks will occur. It's not a question of when or if, but a question of when.
Okay, thanks, Paul. This is Rich Kovac speaking now. Greetings, everyone. And I'd like to take a few minutes to talk about new technology that's available that will greatly minimize and even eliminate some of the maintenance considerations that Paul spoke of. Okay, here we have the new Envision diaphragm valve, our new technology, which features the quick change bonnet, for example. No tools are required to remove the bonnet and replace the diaphragm. And consequently, there is no need to torque any fasteners because there are none. There are no shell leaks during thermal cycling due to the thermal compensation system, the active thermal compensation system, I should say. And again, there are no loose fasteners, and this is one of my favorite features because I can relate an experience from early in my career. The first time I ever attempted to troubleshoot a valve at a customer site, a diaphragm valve, I removed the fasteners, the nuts and bolts, and promptly dropped them through a grating into a canal. Needless to say, the customer was not impressed. So again, with Envision, there are no fasteners to lose or gall, no tools required, no need to torque or retorque, and no reduction in performance from thermal cycling. Okay, looks like we have a polling question at this time.
Okay,
Jennifer?
thanks, Rich. I've lost some fasteners in my time as well, so that also sounds good to me. We'd like the audience to give their input. Which is the most important valve feature for your operation? We have the choices are no tools required, no loss of seal integrity during thermal cycles, minimized risk of contamination, quick change bonnet, and no fasteners. So please click on your answer and then hit submit. Again, it's which is the most important valve feature for your operation. No tools required, no loss of seal integrity during thermal cycles, minimize risk of contamination, quick change bonnet, and no fasteners. And in a minute, we will pull up the results of that polling question. And the results are the two largest categories. We've got 48% chose minimized risk of contamination, 36% chose no loss of seal integrity during thermal cycles, and then a small percent chose the other benefits, no tools, quick change bonnet, and no fasteners. So Rich, would you like to continue with the presentation?
Please. All right, I just want to talk about the diaphragm installation for Envision. The diaphragm stud is shown on the right, and as you can see, it's not a threaded stud as traditional diaphragms typically use, but it facilitates a push and turn installation that's foolproof because it's impossible to over-thread it or under-thread it. The stud with flats fits into the slot on the compressor, which is pointed out on the left. There's no need to invert the diaphragm and no worry about incorrect installation. It's foolproof and therefore no concern with point loading. Also, you can see on the bottom of the bonnet the 4 key slots. These are used to attach the bonnet to the body rather than the traditional fasteners. There's more on that on the next slide. Okay, again, so we're pointing out the bonnet key slots, which you can see from below on the left-hand view and then in a cross-section in the right-hand view. With this design, the valve body has permanently installed studs, and you can see they have kind of a mushroom head shape there. So they're, again, permanently installed into the body, and then they fit into the key slots on the bonnet. So to install the bonnet, the user simply drops the bonnet over the studs and then rotates the bonnet to the latched position. So again, in this cross section on the right, you can see the bonnet attachment by the stud and key slot arrangement. Above the body, you have the diaphragm, backing cushion, pressure ring, and spring washers. The pressure ring clamps the diaphragm to the body and is energized by the steel spring washers. Since the steel springs do not thermally degrade like the traditional backing cushions do, this system is much more robust against external leakage. As mentioned previously in Paul's presentation, we've exposed this valve to 500 thermal cycles with 0 reduction in leak tightness. Further, you can see the spring washers are loaded from above by a gear train, which the user operates by turning the bonnet cover. This gear train gives the user a mechanical advantage, which eliminates the need for tools. So in a sense, the tools are built in. Another feature, a locking pin, stops the bonnet cover at the exact position when the diaphragm is loaded to the correct clamping pressure. Again, a foolproof design. Just a little bit about the hygienic design. Traditional diaphragm valves, and there's two styles illustrated here, can have small entrapment areas. For example, valve design 1, valve type 1, can trap material between the diaphragm bead and the edge of the body, particularly with the diaphragm in the closed position. So this can prevent complete cleaning. The second design has both a body bead and a diaphragm bead, building in a small area where material can accumulate, and again prevent complete cleaning. But with Envision, there is a bead on the body adjacent to the body cavity, but no bead on the diaphragm. Thus, as you can see, there are no points of entrapment. The valve design is completely cleanable. So, what are the benefits to the user of the new technology? Typical diaphragm valves require an average of 23 minutes for diaphragm replacement, including retorquing after a thermal cycle. Envision requires approximately 3 minutes for a diaphragm change. There are no hassles using tools in tight spaces. Assembly is simple and foolproof, and no threaded fasteners to lose or damage. Finally, the external seal is robust against thermal changes and does not degrade with time. Maintenance costs, as a result, are much lower, and maintenance outages are shorter, which means more production uptime to make biopharm products.
Okay, thank you, Rich. Again, our key takeaways from today's presentation. Diaphragm valves leak because of maintenance issues, fastener condition, installation error, and diaphragm usage beyond its useful service life. Maintenance best practices can certainly lower the contamination risks, alleviate the potential for lost batches, and increase profitability. However, there is new technology available today that can increase productivity, extend maintenance intervals, and reduce downtime and total cost of ownership.
Okay. Thank you so much for that informative presentation, Paul and Rich. I appreciate that. And we are going to get started on our question and answer session. So let me remind the audience how to submit questions. You can submit questions by typing them in the Q&A box, which can be found on the right-hand side of the presentation window. We will try to answer as many questions as we can. So our first question that we have, has the Envision valve been installed by any pharmaceutical manufacturers?
Yes, it has been installed by a significant number of major pharmaceuticals in a very wide range of applications, from CIP processes to ultrafiltration skids. It's being implemented quite frequently now at a very accelerating rate.
Okay. And one of the things that you mentioned was the ASME BPE Appendix J test. Can you tell us maybe briefly a little bit what exactly that is and where more information can be found out about that?
Yes, so the ASME BPE, the Bioprocessing Equipment Standard, has an Appendix J test, which is a test that cycles between steam and ambient conditions. Currently, it's limited to 500 thermal cycles. The details of that test is available within the ASME BPE standard, which is available at the asme.org website. That can be downloaded there. Also, folks can actually contact us as well, and we can give them some details there. It's currently pretty much a steam thermal cycle type test, but the BPE is actually working on increasing that to include more chemical resistance as well. So that will be changing as time goes forward.
Okay. All right. We have another question. What fastener lubricants have been used by your customers in the past?
We're not privy to everything, but we do know that White Knight has been used. We do know that a Chevron, which is similar to what we use in our internal valve lubrication, is used. It's FDA acceptable. Food grade greases. There's quite a number. It's food grade is the basic requirement for that.
Okay. All right. Thank you. What size ranges are available for the Envision valve?
The Envision is available 1/2 inch through 2 inch pipeline sizes.
Take that one.
Another question, can you discuss actuator installation?
Yes, the Envision, I'm assuming this is related to the Envision valve, and the Envision is available with actuators, pneumatic actuators, and they're integral to the valve, and installation is of those is similar to a traditional diaphragm valve. So I hope that addresses the question. Please send in another question if it doesn't.
Okay. We have another question about sterilization. Is it possible to sterilize the valves by autoclave, by actually taking the valve and putting it inside the autoclave and sterilizing?
Yes, the Envision has an autoclave. It's made of autoclavable material, and we have an option for sealing it for autoclave use.
Okay. Now, you mentioned that the valve is being used in pharmaceuticals, and one of the listeners would like to know how long have the diaphragms been in the field. I'm not quite sure if that question was related to diaphragm valves in general or the Envision valve. So maybe you could answer.
I would assume the Envision, and we have valves that have been in place for over 1.5 to 2 years.
Okay. Very good. So let's see. We have a couple more questions coming in. Is the Envision valve available on block body style valves?
Yes, the Envision is available on any of the standard type block body valves and even custom block body valves. The unique nature of its installation, it can be used on both two-way type valves and block bodies.
Okay. And another question. What type of diaphragm is available for the Envision valve?
The Envision is only available with the PTFE type of diaphragm. We elected to use the PTFE because with the Envision technology, we're able to have a diaphragm that has the steam resistance and chemical resistance of the PTFE while still being able to seal like an elastomer type diaphragm because of the unique sealing features that we have.
Okay, excellent. That is a lot of really good questions, and we appreciate the audience answering or sending their questions in. And if we haven't gotten to some of your questions, these will be available, and we'll try to get to some of these offline. I wanted to give you a little bit more information about how you can access the webcast. But first, I want to thank the audience for their questions and their participation, and certainly thank our sponsor, ITT Engineered Valves, for making today's educational webcast possible. And the webcast will be available for on-demand viewing through September of next year. You will receive an email from Pharmaceutical Technology alerting you when this webcast will be available for replay. And we invite you to forward that announcement to your colleagues who may have missed today's live event, and they can listen to it as an on-demand viewing. So thank you again, and we'll see you next time. Goodbye.